What if I told you we could get to Mars in just 3 days? Sounds like science fiction, right? But with groundbreaking advances in space travel technology, this might soon be our reality. Traveling to Mars is no easy feat. There's a reason why humans have never set foot on the red planet. The journey is long, dangerous, and packed with challenges that make it one of the most ambitious missions humanity has ever considered. A round-trip mission to Mars takes a staggering 21 months. 9 months to get there, 3 months on the planet, and another 9 months to return. Every second of that journey translates into massive costs, physical tolls on the human body, and logistical hurdles. But what if we didn't have to wait that long? What if we could cut the journey time drastically? From nuclear rockets to ion engines and even photonic propulsion, revolutionary technologies are promising to redefine space travel as we know it. Let's start with the technology that's already making waves. SpaceX's Raptor engines. These next-generation engines burn liquid methane and liquid oxygen, producing immense thrust while being fully reusable, a game-changer for reducing costs and increasing efficiency. While this propulsion system could take us to Mars in about 9 months, scientists and engineers are looking for ways to go even faster. Enter the nuclear-powered rocket, a concept that could cut travel time to just 90 days. By using uranium to generate heat, these rockets would produce twice the thrust of current chemical systems. Despite concerns about nuclear energy, modern safety measures and designs ensure minimal risks, especially since the reactor wouldn't even activate until the spacecraft left Earth's atmosphere. But what if 90 days isn't fast enough? That's where ion engines come in. By electrically accelerating ions to generate thrust, these futuristic engines could propel spacecraft at speeds of up to 200,000 miles per hour. Though the acceleration starts slow, once in the vacuum of space, ion engines deliver continuous propulsion. With this technology, a trip to Mars could take just 39 days, a significant leap forward. Among the many groundbreaking advancements in space travel, one concept stands out as truly revolutionary: photonic propulsion systems. This technology, which uses particles of light known as photons to propel spacecraft, represents a paradigm shift in how we envision traveling through space. Imagine cutting the journey to Mars from the current 9 months to just 3 days. It sounds like science fiction, but the principles behind photonic propulsion are grounded in real physics, and the implications of this technology could be nothing short of transformative for humanity's future in space. To understand how photonic propulsion works, we need to delve into the unique properties of photons. Unlike traditional propulsion systems that rely on chemical reactions or nuclear energy to generate thrust, photonic propulsion taps into the momentum carried by photons. While photons themselves are massless, they possess both energy and momentum. When these particles of light strike or reflect off a surface, their momentum is transferred, creating a small but measurable push. This phenomenon, often compared to a gentle but continuous nudge, is the principle that drives photonic propulsion. Now, you might wonder how such a seemingly tiny force could power an entire spacecraft. The answer lies in scalability and sustained acceleration. While the initial thrust generated by photons is minuscule compared to the explosive power of chemical rockets, photonic propulsion systems rely on the fact that in the vacuum of space, there's no air resistance or gravity to slow a spacecraft down. This means that even a small, constant force can build up incredible speeds over time. Given enough time and precision engineering, a spacecraft propelled by photons could reach extraordinary velocities, enabling it to cover vast distances in record time. One of the most promising concepts for harnessing photonic propulsion involves the use of highly concentrated laser beams. These lasers would be stationed on Earth or in orbit and directed at a lightweight spacecraft equipped with a highly reflective sail. This light sail, designed to capture the energy and momentum of the photons, would essentially be pushed forward by the laser's beam. The intense focused energy from the laser could accelerate the spacecraft to unprecedented speeds, potentially enabling it to reach Mars in just 3 days. Despite its immense promise, photonic propulsion is still in its infancy. Developing the necessary technology to generate, aim, and sustain powerful laser beams over vast distances presents significant technical challenges. The materials required for the light sails must be both ultra-lightweight and highly reflective, capable of withstanding the intense energy of the laser without disintegrating. Additionally, there are concerns about aiming precision, as even a slight deviation in the laser beam's trajectory could send the spacecraft off course. From cutting-edge chemical engines to nuclear reactors, ion thrusters, and photonic propulsion, humanity is on the brink of a space travel revolution. These advancements could make Mars more accessible than ever and open doors to a future where interplanetary exploration becomes a regular part of our lives. What do you think about these futuristic methods of space travel? Which one excites you the most? Let me know in the comments below. And don't forget to like, subscribe, and hit the notification bell for more content on the latest breakthroughs in space exploration. The future of humanity among the stars starts now. Imagine traveling from New York to London in just over 3 hours, cutting transcontinental travel time in half. It's a dream that's closer to becoming a reality than ever before. But can we overcome the challenges of supersonic travel to make it practical, affordable, and safe? Let's dive into the cutting-edge technology shaping the future of aviation. For decades, the idea of ultra-fast aircraft capable of crossing continents in mere hours has captured the imagination of engineers and travelers alike. While aviation giants like Boeing and Lockheed Martin are advancing hypersonic missile technology, a groundbreaking company named Boom Supersonic is tackling a different challenge, bringing back supersonic passenger flights. With their XB-1 demonstrator and ambitious Overture airliner in development, the dream of supersonic travel might soon become a reality. But is this vision practical, and are we truly ready for such rapid advancements? Let's find out. The concept of hypersonic and supersonic flight has a long and turbulent history. Aerospace historian Richard P. Hallion once compared faith in hypersonics to belief in the second coming. Everyone knows it's possible, but no one is sure when it will happen. For over 60 years, hypersonic technology has seen cycles of interest and stagnation. Early challenges with rocket engines, re-entry protection, and air-breathing engine designs deterred progress. The Cold War-era military focused on traditional fighters and bombers, sidelining hypersonics due to their steep technological barriers. Today, however, hypersonics and supersonics are resurging, fueled by advancements in materials, engine technology, and the geopolitical arms race. Hypersonic weapons are viewed as game changers by the Pentagon, while companies like Boom Supersonic are looking beyond military applications to revolutionize commercial air travel. Boom Supersonic's XB-1, affectionately nicknamed Baby Boom, is a scaled prototype paving the way for the Overture, a supersonic passenger jet designed to carry 65 to 80 passengers at Mach 1.7. That's twice the speed of today's fastest commercial airliners. The XB-1's innovative design includes advanced composite materials, titanium, and stainless steel capable of withstanding extreme temperatures. Its sleek, swept-wing structure minimizes drag and maximizes efficiency, while its 3 General Electric J85-15 engines provide the power needed to break the sound barrier. But the real game-changer lies in Overture's promise to solve the long-standing issue of sonic booms. By flying supersonic routes primarily over oceans and subsonic over land, Boom's team aims to eliminate disruptive noise pollution. The Overture also leverages sustainable aviation fuel, SAF, striving for net zero carbon emissions, a nod to the increasing demand for eco-friendly travel. Despite setbacks, including pandemic-related delays, Boom has made remarkable progress. In 2023, the XB-1 completed its ground testing in subsonic flights, demonstrating its stability and efficiency. The company now aims for its first supersonic test flights in 2024 and plans to have the Overture ready for commercial service by 2029. The path to revolutionizing air travel with supersonic speeds is not without its hurdles, and one of the most significant challenges is cost. The Overture, Boom Technologies' ambitious supersonic airliner, comes with an estimated price tag of $200 to $250 million per jet. This high production cost will inevitably influence ticket pricing, especially in the early stages of commercial operations. The parallels to the iconic Concorde, which charged passengers around $10,000 for a transatlantic ticket in the 1990s, roughly $20,000 when adjusted for inflation, are hard to ignore. These steep prices made the Concorde a luxury experience, accessible only to an elite few, and the fear is that Overture might face the same initial exclusivity. However, Boom Technology has a bold vision that extends far beyond catering to the wealthy. The company's ultimate goal is to make supersonic travel accessible to the masses. Blake Scholl, Boom's CEO, dreams of a future where traveling across the globe at supersonic speeds isn't a privilege reserved for the few, but a reality for many. The dream includes ticket prices dropping to as low as $100 for a 4-hour global journey, a proposition that sounds like science fiction today. Achieving this goal will require breakthroughs in not only technology, but also manufacturing efficiency, operational scalability, and partnerships with airlines willing to invest in a new era of air travel. The race for supersonic travel is heating up, and Boom Supersonic is at the forefront of this groundbreaking movement. With their innovative designs and ambitious goals, they might just redefine the way we travel. But will supersonic flights ever become as commonplace as modern subsonic airliners? Or will the challenges of cost, noise, and infrastructure keep this technology out of reach for most travelers? Let us know your thoughts in the comments below. If you enjoyed this journey into the future of aviation, don't forget to like this video, subscribe to the channel, and hit the notification bell for more insights into cutting-edge technology. Thanks for watching, and we'll see you in the next video.